part 194, line 18E2, ideal gas law, point particles, internal kinetic energy, Wow Seti. There's the alien radio signal. This is just data only, just so you know. This is from Wiki. An ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting point particles. The ideal gas concept is useful because it obeys the ideal gas law, a simplified equation of state, and is amenable to analysis under statistical mechanics. At normal conditions such as the standard temperature and pressure, most real gases behave quantitatively like an ideal gas. Many gases such as air, nitrogen, oxygen, hydrogen, noble gases, and some heavier gases like carbon dioxide can be treated like ideal gases within reasonable tolerances. Generally, a gas behaves more like an ideal gas at higher temperatures and lower density. As the work performed by intermolecular forces becomes less significant compared with the particle's kinetic energy, and the size of the molecules become less significant compared to the empty space between them. The ideal gas models tend to fail at lower temperatures or higher pressures. When intermolecular forces and molecular size become important, it also fails for many heavy gases such as water vapor or many refrigerants. At some point of low temperature and high pressure, real gases undergo a phase transition such as to liquid or a solid. The model of ideal gas, however, does not describe or allow phase transitions. These must be modeled by more complex equations of state. The ideal gas model has been explored in both the Newtonian dynamics, as in kinetic theory, and in quantum mechanics as a gas in a box. The ideal gas model has been used to model the behavior of electrons in a metal, in the Drude model and the free electron model, and it is one of the most important models in statistical mechanics. Internal energy of a closed thermodynamic system. This above summation of all components of change in internal energy assume that a positive energy denotes heat added to the system or work done on the system, while a negative energy denotes work of the system on the environment. Internal energy of the ideal gas. Thermodynamics often uses the concept of the ideal gas for teaching purposes and as an approximation for working systems. The ideal gas is a gas of particles considered as point objects of perfect spherical symmetry that interact only by elastic collisions and fill a volume such as that their free mean path between collisions is much larger than their diameter. Such systems are approximated by the monoatomic gases helium and the other noble gases. Here the kinetic energy consists only of the translational energy of the individual atoms. Monoatomic particles are not considered to rotate or vibrate and are not electronically excited to higher energies except at very high temperatures. So what it's saying is you can use these monoatomic particles, but you need to use them at a very high temperature. Okay. Therefore, practical internal energy changes in an ideal gas may be described solely by changes in its kinetic energy. Okay, that's the end of that video. We'll go on to the next one.